actually. We want to solve some systems of equations by using what's called Cramer's rule. So here's a system of equations that I've solved previously. What I want to do is solve it by Cramer's rule. Now, Cramer's rule requires that you form some determinants. The determinant big D is the determinant of just the coefficients of x and y in the system of equations. So it'll be 2, -3, 4, 5. Now, that determinant's easy to evaluate. That's going to be 2 times 5 is 10. Subtract 4 times -3, which is -12. So 10 plus 12, which is 22. Now, the next determinant I form is called d sub x, and it's the same as this determinant d, except where the coefficients of x were, we replace those with the constant terms. So instead of these coefficients of x, I write the constant terms for 3. Otherwise, the determinant stays exactly as it is. So d sub x means I've substituted the coefficients of the constant terms for the coefficients of x. Now I evaluate this. 4 times 5 is 20. Subtract 3 times -3, which is -9. 20 plus 9, 29. The determinant d sub y is the same as my original coefficient determinant, except that in place of the coefficients of y, I use the constant terms. So it's 2, 4, that's these numbers right here. Then in place of these, I use the constant terms. So I evaluate this. 2 times 3 is 6. Subtract 4 times 4 is 16. And I end up with -10. Now to solve my system, x, the x-coordinate of the solution to my system will be d sub x divided by d. d sub x divided by d. And you could check this by solving this system by some other method. d sub x is 29, d is 22, so I have 29 divided by 22. That's the x-coordinate of my point of intersection. Y is equal to d sub y divided by d, and that will be -10 divided by 22, which is -5/11 if I reduce it to lowest terms. I don't have room to do that here, so I won't write it. But in any case, what I do is simply form these determinants. A very mechanical process to solve a system of equations by determinants, so it lends itself well to calculators or computers. You simply form these 2 by 2 determinants like this. The value of x that solves this system of equations will always be d sub x divided by d. The value of y that solves this system of equations will always be d sub y divided by d. So these two, this is the ordered pair, x, y, that satisfies this equation. And no matter how you solve this system, you'll get that same ordered pair. Let's try Cramer's rule now with a 3 by 3 system. To use Cramer's rule here, we first form the determinant big D, and it's the determinant of the coefficients of x, y, and z now. So in my first equation, I have 1x, 1y, and 0z. In my second equation, I have 2x, 0y, and -1z. In my third equation, I have 0x, 1y, and 2z. So that's my determinant big D, and it's the determinant of just the coefficients of x, y, and z in my original system. Now I'm going to form my 3 more determinants, d sub x, d sub y, and d sub z. d sub x will be what I get when I take the coefficients of x and replace them with the constant terms in this determinant. d sub y will be what I get when I take the coefficients of y and replace them with these constant terms. And d sub z will be what I get when I take the coefficients of z and replace them with the constant terms. So let's look at d sub x. d sub x will look just like this determinant, except that instead of these coefficients of x, I use the constant terms. -1, 3, -1. The rest of this determinant stays exactly the same. 1, 0, 1. 0, -1, 2. So that's d sub x, and now the x-coordinate of the point where these 3 planes intersect is d sub x divided by d. So if I evaluate this and evaluate this and take the ratio of d sub x to d, I get the x-coordinate of this system. So I'm going to write up here x is equal to d sub x divided by d, where that's d sub x is what I get when I evaluate this, and d is what I get when I evaluate this. Let's go ahead now and form d sub y. It will look just like this, except instead of the coefficients of y, I'll use the constant terms. So 1, 2, 0, that won't change. 0, -1, 2, that won't change. But instead of these coefficients right here of y, I use the constant terms, -1, 3, -1. And then d sub z will look just like this determinant, except instead of the coefficients of z, I'll use the constant terms. So 1, 2, 0, that won't change. This won't change, 1, 0, 1. But instead of these coefficients here, I'll use the constant terms, negative 1, 3, negative 1. Now, when I solve this system, evaluating these determinants, there's a lot of different ways to do it. I'm not going to show the work. This example is actually in the book, so you can follow along in that example or try these on your own. But when you do find these determinants right here, y will be equal to d sub y divided by d, and z will be equal to d sub z divided by d. So I can find my coordinates x, y, and z that satisfy this equation by finding these three ratios right here. Sometimes what people like to do, if it's a simple system, is maybe just find one of the ratios and then back substitute to find the other values of x and y. It just depends on when you want to stop using Cramer's rule with a system like this. I would try all of these yourself, make sure you get a value for each one of these determinants, form these ratios, and see if that isn't a solution to that system of three equations and three variables.